A common data structure that most programmers need to learn is how to use a tree. There's a lot of different types of trees out there, and we're going to start off with probably the easiest tree, which is a binary tree. A binary tree gets its name because you have a single element, and from that element, you can have at most 2 child nodes. Now, what use would that be for you? Well, it's quite simple. Binary trees provide a very easy way to get a sorted list of data and to do a binary search. Now, this is assuming that we have what's known as a well-ordered binary tree. That means that it's equal in its left and right branches. Now, you might say, well, how does that work? Well, let's take a look at an example of a binary tree. As you can see, we start here with the number 8. When I go to add a new node, let's say it's 3, I'm going to look and say, okay, is 3 less than or greater than 8? Because it's less, we move to the left-hand side. We add 10, 10 being greater than 8 moves to the right-hand side. We add 6, 6 is less than 8, we find our node for 3. But 6 is greater than 3, so we move to its right-hand side. And as you can see, we have kind of this formula for doing this. I don't ever move existing nodes, but based upon what size my node is, I will constantly move things to either the left or the right. This makes it very fast and easy to do insertions, very fast and easy to do searches. Now, removing a node is a little bit more of a challenge because now we have to figure out what are we going to do with all those children nodes. Usually the easiest is we go back and simply add them again. So one of the nice things about a binary tree is the fact that it can be done with a single data object. It's going to have a value, which is going to be used to store whatever value we're using. Now, I've used numbers because it's very easy to see, but we could have just as easily stored employees or products or anything else we needed to. Likewise, we have references to 2 other data elements. Outside of that, we have no real need. If I'm using an object-oriented language, I can create the methods I need all within my one class. All I need is that very first top node to work with, and everything else works great. Now, while there are a lot of other trees out there, they work on a similar type of basis. Maybe not quite as easy as a binary tree, but the same basic idea of having parents and children. And if you can get this concept down, it's easy to move into other types of trees.